Hello and welcome back to another episode. So last time we looked at a serverless retract, and today we're going to look at a servo. That's not very exciting, I guess, but we're going to do something special with it. We're going to go and convert it from potentiometer to a Hall sensor, and hopefully it will become clear why we might be interested in doing that. I'm going to use a so-called Towered Pro 946R, and so this is a rather common servo. It has quite a solid all-metal drivetrain. You can see the spelling of Tower Pro is a little bit off, or with all these Chinese clones of another clone, and I don't fully know what's going on here. This is supposed to be the high torque version of the famous and infamous 995. So if we reattach the servo horn and have a look at what my servo tester says, so you can see that it covers the full range down to 800 microseconds. As well as the full range up to 2200 microseconds. So if your radio supports that, then you have not quite 180 degrees, let's say 160 degrees, which is quite common for this type of servo. Yeah, so people do all kinds of things with these. One popular conversion is to take out to disable the potentiometer and convert it to a continuously rotating gear motor, either using the servo electronics as a speed controller, or using a dedicated speed controller, which might be a bit more powerful or more finely grained, or have a better neutral position. And there are plenty of videos on YouTube where you can learn how to do that. We're going to do something a little bit different. Okay, I'm back. So, and while disassembling the servo, I noticed that does this work? This is indeed a Tower Pro servo. So, despite the label being completely misspelled, the internal quality check sticker spells Tower Pro correctly. Interesting. So, inside this converted servo is probably the worst hack job known to humanity. I took out the default servo and spliced in a little Hall sensor, and hopefully we're going to see what happens when I reassemble the servo. I also, more importantly, converted it to continuous rotation, so we'll be able to verify that in a second. So let's fold everything where it belongs. Really sorry about the focus. If I'm going to do more of this small stuff, I'll probably need a better solution than this zoom lens with a diopter, macro diopter. Okay. One thing I did not do, which you really should do, is re-grease all of the gears. Not only because you probably have handled them with your hands and wiped off a bit of the grease, but also because these servos come with pretty limited amount of grease in the first place, and the output gears, of course, only intended to rotate for less than 180 degrees. So yeah, I guess someone can save like a fraction of a cent by having less grease in these servos. So you might want to remedy that when you're disassembling your servo. So do as I say, don't do as I do. Okay, so this looks like an almost normal servo, but of course we have more wires coming out. Interesting. So first off, we're going to plug that in to my trusty speed controller, servo tester, and we can see we have a nice gear motor that is controllable. It's one of the problems with these servos is because they are intended to be used in a closed loop operation, and now we have removed the feedback effectively. They are a little bit touchy to control. So normally we would expect full speed at, I don't know, not the 2200 microseconds, but let's say 1800 upwards, and pretty much at 1550 we are already probably even earlier, we are at full speed. So if you want to use your servo as a gear motor and you're only really interested in full speed one direction, full speed the other direction, and a little bit of smoothness in between, it's a good idea to keep the servo electronic. If, however, you want to have fine-grained control, you might want to spend the money to get a speed controller. But this is not what this video is about. So we set this to rotate. And what I have here is a very powerful magnet and a Hall sensor is nothing but a sensor that measures a magnetic field strength. So you can see how it works. Quite marvelous, huh? So there you have it. Servo controlled by a Hall sensor and a magnet. Currently only suitable for servos that do a very limited amount of travel and sensitive to misalignment. So you might ask, why are we interested in this in the first place? And well, common advantages of Hall sensors are that they are contactless, so they have no wear and no tear, and potentiometers too, especially the rather cheap ones that are in many of the cheap servos. but as you can see, there are also some problems associated with using them, at least on this very low-cost approach that I'm showing here today. So another option or another advantage is that they are quite small. You just need a magnet and this tiny sensor, and you can install them anywhere in your mechanism that you're driving with either the servo or a gear motor that you're using together with the servo electronic and the sensor as a servo. So yeah, I think it's an interesting idea. Obviously currently it still has problems, but hopefully in the future I can solve them, and if I do that, or if you have any ideas, then please let me know, and I hope to see you again sometime soon. Thank you very much for watching. Until next time.